And moving on to Chris Waller. So Chris Waller is Vice President and Chief Scientist at EPAM Systems. He has a long history in the pharmaceutical industry, working at Merck, and basically starting from CUSA in his postdoctoral work. So he will talk about the digital lab of the future.
Thank you, Stefan. Thanks the organizers again for having me back again. It seems like I've been doing link stuff for a very long time now. And thanks to all the morning speakers. They've been fantastic so far. So I'm going to do something different. We're going to have fun. Kidding, speakers. You know, this is a talk that's fundamentally different than talks that I usually give. I think the last time I talked to you guys, I talk a lot about data science. And
snap your W2.
Let's start with this. Let's give this a go. Oh, we got to get by the commercial first. So I'm working on a new project. I'll explain it. So the kitchen of the future.
This is the Molly Robotic Kitchen.
Only a couple of minutes, but it's highly entertaining. In your spare time, go to Google or YouTube and just query kitchen of the future. IKEA does a hell of a lot of work in this space, and it's really fun. You have an app that will control your kitchen. Talk about, you'll see obvious similarities between what I think All right, that's probably good enough. Just feel that we can talk about this. So, yes, this lady's off doing important things while the kitchen's cooking, right? So, yes, as Stefan said, after about 25 years of bouncing through sort of government, biotech, startup, mid-pharma, large pharma, I quit in the spring and decided to work on my golf game and see how that was going to go. By the summer, my wife had said, you really have to go back to work, and because your golf game's really bad and you're driving me nuts. So I took a sort of an interesting turn, and I went to work for this company called EPAM. It's probably one of the largest companies you've never heard of. We're about 26,000 people spread primarily across Eastern and Central Europe. There's over 20,000 software engineers that build stuff. They were my primary outsource provider at Pfizer and at Merck, so they built all the applications that my research scientists use that we built. Within life sciences, and life sciences and healthcare, I function as a chief scientist, and I have a business consulting role as well. So it's kind of similar to what I did, but it's different. So now I'm a sales guy, right? I go out and talk to people about selling things. I'm a horrible salesperson. So far I've sold nothing. But what I'm working on within EPAM is that and within life sciences specifically, is a vision for what the research lab of the future needs to look like. And so this talk is the first time this has ever been shown publicly, so it's a little rough. And it actually got censored a bit this morning by my pre-sales team in Russia. So it's not as long as was going to be. I've got the second half of the talk, which is actually some work that we're doing within the Pistoia Alliance. And if you've not heard of the Pistoia Alliance, it's a pre-competitive collaborative consortium that works on technology solutions that bother pharmaceutical R&D. It's been around for about 10 years now. I was one of the founding members of it while I was at Pfizer. I'm working within that group now as an EPAM employee to promote the Lab of the Future. And there's a work stream and a program around Lab of the Future within Pistoia, which has members from all pharma, basically, and most of our technology providers. And I'll tell you what we're doing there, and I'll invite you to participate if you get excited about it. So let's go to the next slide. Can I just control this? I can. So if you think about the current lab, I mean, many of you are lab-based people, right? Or at least have seen the lab or been in a lab. And the problem that you run into in labs, and that I've highlighted here, it's a little hard to see, but things like lack of seamless data flow, data silos, limited access to integrated data for advanced analytics, fragmented control, and then human errors, right? We've already seen people talk about humans. I think what I'm trying to drive to, what I am trying to drive to, is to a place where it's much more tightly integrated. The data is integrated, the workflows are more holistic, and we talked about the quality of the data. The data are of such a quality that I can instantaneously drive the data into a cloud infrastructure, have it analyzed, have some actionable insights extracted from it, and then the magical hands in the lab are doing something else, right? They're off and running the next experiment. I did a panel session at a recent Basoy meeting where I asked several industry execs what's in the lab of the future. And those are kind of interesting and easy answers, right? IoT is a big thing. I've got a whole slide on that, so we'll talk about it. And I let them go on for a while, so I'm going to ask you a harder question. What's not in the lab of the future? First thing from Alistair Benning from BMS said, people, right? So that's why I brought the arms up there. And I said, I have a similar vision, right? It's a Star Trek kind of vision where you're looking at the lab through the glass and you're controlling it through some sort of haptic interface or whatever, and magic is happening. And that's what all these trends out here on the right of the slide are referring to. That to make that vision real, you're going to have to see things like better connectivity, better collaboration. The systems that you put in place have to be scalable. There's a lot of regulatory and security concerns, advanced analytics, obviously automation, virtualization, and integration. So I picked up on those themes, and I think about the process within the lab and laboratory execution. If you go around the outside of this wheel, there's all about planning and management of the assay. There's actually the execution and the data capture part of it, and then there's the integration analysis and the AI that you're going to do to figure out what you should be doing next. And in the center of that wheel is collaboration. And I think the other trend that I'm seeing in labs and the pharma execs are picking up on is that laboratories are going to be highly distributed, right? You may be doing work across the country, and most of you are, right? Within Lineage, you're working together anyway. So collaboration and those platforms to promote collaboration are going to be much more important. You can't read this as an eye chart. You can download it if you like it. And what I've done is attempted to map, from my perspective, where the technologies that EPAM specifically has some capability map onto this wheel, right? Because this is a promotional slide deck that I'll use to try to sell some stuff. Not to you guys, this is just entertainment for you. So we talked about this a little bit. People are familiar with hype cycles, right? This is the technology hype cycle for 2017. And I look at it much like a roller coaster, right? You go on a roller coaster, you're all excited, you're going up, ching, 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 ching. It takes forever to get to the top. You get to the top, you're overly excited, it's going to be exciting, yay, 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 and you fall down, you're screaming the entire time because you may die. And then you get there and you're like, oh, that wasn't so bad. And now you're finally in a place where you're going to be. Look at the very top of the hype cycle. Right now, machine learning is at the very top, ready to get and go down that hill, right? So it's like last year it was data science. 2 years before that it was cloud, right? So pick your favorite term, but I think at this point I've attempted to kind of call out some of these technologies, where they are on the hype cycle and how they need to come together to realize that vision. It's not going to be like one big bang in the lab. Is going to be, oh look, we're in the lab of the future. It's going to be an evolutionary process, and these technologies will drive us there. Fun slides to look at. So the next few slides, and I'll go through them very quickly. I basically just said, okay, within this particular area, regulatory security, before making it messed up, what's the most exciting thing do I see in that area? Who likes blockchain? Anybody doing any work with blockchain? If you're not, you will be. Trust me. So here's an example of how blockchain can be used in a data management solution, right? So we have these are all anonymized projects, but we've worked on some exercises and projects where we take in preclinical data and use blockchain just to maintain this. In any kind of situation where you've got lack of trust, blockchain is a great idea because it allows for complete the data to be completely immutable, right? Can never change. And I think that's important when you're dealing from discovery through clinic and dealing with regulatory agencies. So that's kind of fun to look at if you like case studies like that. That one used Ethereum. I was telling somebody this morning, I'm the reason Bitcoin went down. If you guys have been following this cryptocurrency, I invest in things and they immediately crash. So I'm sorry if you have, but I will advise you to invest in Ethereum, which seems to be going up. Connectivity. So what do I like about connectivity? This was a really cool example of one, and many of you have aero gardens and things like that at home for growing herbs and whatever. And this was an example where EPAM did a project, actually a challenge in an IoT space where it's essentially like an aero garden on steroids. It's completely self-contained in terms of how it can take care of everything it needs to do to make these plants happy. So if you think about what I was showing in the previous video, and if you look at the IKEA Kitchen of the Future video, you'll see how there's some similarities here, how IoT has been used to connect a lot of these devices and things are working together to have a really holistic solution. Automation, I liked Pipeline Builder. This is a web-based, what they call it, a WIDL, that basically just allows you to automate your bioinformatics workflows. One of the things that I'll say about EPAM is that as a company, you don't know about us generally because one, we don't have any IP, and two, we white label almost everything that we do. So like our biggest customer is in the financial industry, it's UBS, right? But you don't see EPAM, you see UBS. We're the biggest outsourced provider for Google. We have over 500 people working at Google right now, branded as Google, right? So the point of that story is with everything we do for other people, they own the IP. Certain cases, if they don't want it, we open source a lot of the stuff. So if you go to GitHub, just search EPAM, you'll find a lot of stuff relevant to the things that you do. Some of you guys may know some of this earlier stuff. So the Indigo chemistry cartridge, and there's a sketcher called Catcher, and some things like that are relevant to your lives. Pipeline Builder and some other things are kind of out there in that space too. And if you guys are data scientists, there's an entire data science environment that's been put out there too, called Digital Lab or DLab. Make sure you go to EPAM/DLab, because it allows you to do things like Avi was talking about, take your Jupyter notebook and integrate it with any of the other analytics tools that you want to do in this really nice desktop environment. Scalability, what do I like? This is really cool. This is a cloud, next generation sequencing prototype. So take a peek at that if you're into the sequencing space. I'm blasting through this because I hate standing between you and lunch. Virtualization, now this is a huge deal, right? Everybody's been kind of following what's going on with AR, VR, and HoloLens. And my favorite company, although I'm not really sure that they actually have done anything yet, is Magic Leap. And if you don't know Magic Leap, look up Magic Leap and look at the little girl looking at the elephant dancing around in her palm. It's pretty freaking cool. They're going to do implants to do that. I don't know that I want those. So in this space, there's a lot of work that I had a couple of examples in here, but we're translating a lot of technology from places like oil wells and drilling rigs and things where maintenance techs are wearing HoloLens and they're seeing complete digital twins of the equipment that they're supposed to be working on and getting readings off of the equipment. We're doing a lot of projects like that in companies where they're maybe reinventing their vivariums or things like that, and we're helping them get do better maintenance on things. This is a really simple example of a 3D rendering and a molecule dancing around on the table using HoloLens technology. But it's coming, right? It's becoming mainstream. And it's a great collaboration environment as well. Advanced analytics, I put this one up because this is one of my projects that I worked on at Merck, and we won an Edison Award last year, a silver award, unfortunately. Over beers tonight, I'll tell you about the company, the group that beat us from MIT that built a cyborg stingray. But this was a tool, and almost anybody that's worked in big pharma or a drug discovery lab within academia, you've got web-based tools that allow you to get access to predictive modeling capabilities. And this was one that just integrated all of Merck's capabilities around predictive modeling and brought it to the desktop of the typical chemist. And it was pretty cool. Lastly, I think is integration. And we do a number of projects and where we're pulling data of various types together. It could be genomic data, research data, clinical data, and trying to come up with a way to pull it all together in some meaningful way to provide an integrated analysis capability. And this was one that was called BioTax. It just pulls a lot of different stuff together from a lot of different places. My collaboration one is one that's based on a cloud-based platform where there was a rare disease detection algorithm competition, basically, and it allowed folks to go in and compete on the development of these algorithms to do rare disease detection and collaborate when they wanted to. So there's that one. So I'm gonna make a switch over and talk a little bit about Pistoia, because you'll see a lot of the similarities, and I can talk more freely about the stuff that Pistoia is doing than I can about EPAM because it's completely open. So when I was at Merck finishing up in the spring, I got excited about the kitchen videos, right? And thinking about, why was I watching kitchen videos? Well, we've redesigned kitchens in at least 3 houses, and I've got some sort of crazy ability to do that. And, or at least sickness. And I was thinking very much about, well, you know, within the pre-competitive space, I know pharma are making investments in, you know, is it IoT in the lab? Is it machine learning in the lab? Is it whatever in the lab? And I know those investments are being duplicated across pharma, so let's just go ahead and do a typical Pistoia project, which is pool our resources, pool our effort, pool our money, and do something together to drive this forward. So you'll see a lot of similarities. So when I went and we brought, I think I've got 60 some odd people on the interest group around Lab of the Future. And as I said earlier, it kind of spans pharma, the technology providers, and some of the smaller technology providers, which are really innovative. And we asked them, you know, what's the most important thing in the Lab of the Future, and how can we map them onto the horizons? You know, not surprisingly, Internet of Things comes out again, data integrity standards, blockchain, automation, and augmented reality and wearables. And we already talked about all that in my vision from EPAM. The medium-term opportunities people saw were really around the deep learning artificial intelligence things, which were really the top of the hype. Distributed collaborative research again, and then semantic technology and knowledge. And then lastly, and we didn't talk about any of this, but it's coming on faster than I thought it would, is quantum computing. And then that notion of virtual research, highly distributed virtual research, and then a bigger vision of bringing the lab to the patient. And that's well out of the research space. That's more in the preclinical, clinical space. I'm not going to talk about that today. So what Pistoia does really well is then take people's money. We pool the money from, you know, the membership fees and people that want to support IoT or Lab of the Future type projects, and we run projects as a collective. So we have 3 projects that we're scoping out right now. I'm going to go through them quickly for you. There's one around predictive maintenance using IoT capabilities. There's one around a collective methods database, and I'll tell you a story there. And there's one around a demo laboratory. So IoT is a simple one, right? So all of your equipment in your labs are, you know, generally sitting there hooked to some sort of, you know, maybe a computer or just doing their jobs. There's a little company called Tetra Science based in Boston that is, you see this little red box? It's collecting data off of this machine and pushing it straight to the cloud. And in this case, I think it's energy consumption data or something like that, but it could be anything you can monitor and push it straight to the cloud. And then you can do analytics on that. And for the purpose of this one, which was actually the original pilot was run at Shire, and they talked about it publicly, so I'm not giving anything away, where I think they put it on their freezers. And what they were trying to predict was failures, because when the compressor goes down, the freezer goes down, you lose whatever's in there, right? So that was really what got us motivated to think about doing a bigger pilot around that, and think about incubators, and think about analytical equipment, and think about balances and all these other things. So there's a project being put together now across Pistoia to do just that, a much, much larger scale effort to collect the data, do the analytics on it, and have pre-competitive capabilities around doing predictive maintenance. It sounds trivial, I know, but if we can do that, we can do a lot of other things. And these are the reasons, you know, why we're doing it now. I've already gone through most of this stuff. And so this is just the thing, you know, get Tetra Science to come in, install the devices, collect the data, put it all in one big database, do the analytics, and then there's a peak that says there's some energy consumption peak or something that generally, what I've learned is it's indicative of compressor failure when you start sucking a lot of energy. I didn't know that. So anyway, these are the kinds of things they work on. The second one was actually motivated and brought to us by Merck. If you keep up with the sort of pharma news at all, after I left Merck, and so it wasn't my problem, I didn't cause it. In the summer, they had a cyber attack, right? The Petra virus, the not Petra virus, whichever one that got unleashed from Ukraine, made it to Merck and took Merck's research labs and all of their manufacturing offline. And bring, and you know, the way that it worked, it locked everything on the C drives, right? And it demanded a ransom to unlock the C drives so you could get your data back. Merck said no. So Merck had over 70,000 PCs in the laboratories that they had to replace. The manufacturing stayed offline for about 6 months. It was almost impossible to get manufacturing back online. So Merck came in and said, one of our biggest problems was we keep our methods and our protocols on our C drives attached to the computers that run the devices. A very simple solution is push it straight to the cloud, right? So cloud-based methods databases. And if you do that, then you set up an environment to do much more collaboration and sharing across the methods, which, you know, to Tudor's point about targets, which I don't necessarily agree with. I think methods themselves in the lab around how you're going to do an HPLC run on some sort of component are probably a bit more pre-competitive, and there are opportunities to do a lot more sharing there. So in the short term, there's a database. Longer term, there's a bit more things around it. But I think that's a pretty straightforward exercise. And you know, in the case of Merck, when they had to replace all those machines and all those methods were gone, and they're trying to look for backups and all that, it would have been a very simple, restore, right? You blow all the C drives away, you load them back up again, and move on. The third one that we're working on, and this is one where I'm asking Pistoia to kind of put on its big boy pants, like it's make real investments, right? Pistoia has been around 10 years. We've been doing a lot of different projects around. Maybe it's a data standard for the expression of macromolecules. So if anybody works in that space, Helm is something that Pistoia came out with and supports. I've been proposing for a number of years now that, you know, to Tudor's point again, semiconductor companies invest together in facilities to do, you know, mutually beneficial research in a pre-competitive space. So you have Hitachi and Sanyo and Samsung who are working together to solve problems. And then they differentiate their offerings in the market. We know that. There are opportunities to do this in the lab space. So I've asked Pistoia to think about making a physical investment in a lab space where Pistoia members could come in and actually work on pre-competitive projects together. They could be IT, they could be real. What does a lab of the future look like? How do we lay that out? What does the equipment look like? And it's bring your vendors in, let them show their best of breed solutions, and run them with it. Well, it turns out it wasn't a completely unique idea because this is Francis Crick to show you how beautiful some of the designs can be. But there's the Fraunhofer, which is spelled wrong on here. Fraunhofer Institute has a demo lab in Stuttgart where they do just that. So I'm going over there in the spring to chat with them. There's also a lab at NC State University that's slightly similar. It's actually a small replica of Merck's biomanufacturing facility sitting down in Durham. So it's a room about this big. And there's a consortium that works with them called BioForum, which is a manufacturing consortium. And their members can come in and do experiments on this piece of equipment where they're doing new protocol development or they're testing out new equipment. And it's a very similar concept. So the idea is, can we find the space, make it available, share it, and grow together? I think this is almost last. But lastly, the hackathon yesterday, a screaming success. I love hackathons. I think that, there's all kinds of cool stuff that comes out of them. Pistoia sponsored a number of hackathons over the year in conjunction with its conferences. We do one annual conference in the U.S. and one in Europe. The one coming up in March. What is that? Anyway, 12 and 13, I think is what it's supposed to say. In London, we'll have a hackathon there too, where part of that hackathon will be related to Lab of the Future, and we're talking to some of the vendors now, like Tetra Science I mentioned earlier, Cubis Labs, who have similar things. Elsevier is interested in becoming the information backbone of the Lab of the Future. Can they provide some infrastructure and some substrate for a hackathon? So stay tuned, it's pretty exciting. In conclusion, this is like the big wrap-up slide, right? Kind of just reiterating everything I just said. The Lab of the Future is like, I don't know what we keep calling it, the Lab of the Future. Every day, the Lab of the Future, the Lab of the Day is the Lab of the Future, and it's evolving. Like I said, it's not some big singularity event that's going to go, there we go. It's evolving that way. And all of these things have to move at different rates, but they need to be moved in a coordinated manner if we're going to make this thing work and think about it from a platform perspective. And that's what I want to talk about today, and that's going to solve the data problem related to AI, which we'll talk about later, I think. So, the people problem, so I'm gonna let somebody else solve the people problem. You know, think about every problem being, the solution, or every ecosystem has people, process, and technology related to it, right? So everything's gonna change, right? And so if you think about being in big pharma, and you got me going on stuff, I used to do the Six Sigma program at Pfizer, where we go into the labs, we're trying to optimize how the laboratories would work, and you would ask the scientists why you do things a certain way, and they said, well, because he told me to do it that way. You ask that person, so they told me to do it that way, and it goes back and back and back. And sometimes it's like, I come in as an IT person and trying to build a solution to support a broken process. And my point to them sometimes is, sometimes it's easier to take your pants off if you take your shoes off first, right? And it's simple things like that you should think through. So there's going to be a lot of change management to this point still around this, and but you know, it's an interesting way that things are evolving. Data science is changing things.
Yes, I mentioned more like half jokingly, because I don't know, we're gonna have like a discussion panel later in the afternoon with Chris and Leslie, if she agrees as well, and Tudor. It's really meant for students, and perhaps can learn more. Humans will be redundant at some point anytime soon or not.
What if they say this? If you work in a job that's highly automatable, that's bad news, right? Because the robots are coming, and the only job left is going to be robot technician. But the worst news is robots are now fixing robots, right? Thanks, guys.
Yeah, it would be great fun.